Hello everyone, this is Malav Parekh and I'm presenting the Google Gen AI Intensive Course Capstone project for 2025 quarter 1. The focus of this project is to look at the use of RAG to create a chat with knowledge base. Um, so, how to use RAG to unlock the knowledge in your documents and building a hallucination free chatbot. So, while the large language models have been asking made make has have made asking questions easy, the 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 articulated answers are often inaccurate or insufficient. But the alternative is painstakingly scouring through the internet and databases and hoping to find the answer to one question that's been bugging you, leaving you dreading the hours of search. Skimming through a stack of documents, be it research papers, reports, regulatory filings, insurance documents, or lengthy articles for your answer can leave you overwhelmed. And you know the answers you need are in there somewhere, but keyword search or simple, straightforward keywords or just a control F doesn't capture the information that you're looking for, often because the information is not based on that keyword but similar to it. So that's kind of where semantic search becomes useful, and and that is provided by LLMs. Uh, uh, but LLMs provide a lot of hallucination, and that's why it is important to have the ability to just ask questions and get instant accurate answers grounded in content of your specific documents. So that's where RAC, retrieval augmented generation, comes in, which can turn static document collections into dynamic queryable knowledge bases. So as I said, the large language models are like Google's Gemini are incredibly powerful. The problem with them is that they do not give you the specific answers that you're looking for. They often hallucinate. And so the problem is, how can you easily and accurately query a custom knowledge base stored across multiple PDF files using natural language? And you can really replace PDF with a database or other modes of information, right? Can be notes or something else, right? So the solution we're looking for, where we came up with, is use of RAG um, to combine the power of LLMs with a system that can retrieve information from your own data source. Instead of relying solely on pre-trained knowledge, a RAG system first finds relevant information in your documents and then uses the information to formulate an answer. So the approach for that would be, we'll build a RAG system using Google's Gemini model to create a conversational interface that allows you to chat with a collection of PDF documents stored in a Kaggle dataset. The To stay topical, we I used all the white papers provided by the course as data source, using the model to ground the LLM response to the white papers. The PDF files for each white paper was uploaded in Kaggle dataset section for ease of access to those testing this model. The capability used, Gen AI capabilities used here are embeddings, vector search, retrieval augmented generation, grounding, and long context window, um, slightly because it's utilized by the model. So, in all, four in terms of deliberate, and the fifth one as implied. Um, Use case impact. If you see, you can use it for research, you can use it for business intelligence, legal compliance, internal knowledge management, and also to minimize hallucination. Advanced use cases can be in education, RAG on unstructured and semi-structured data, connecting the database for querying multi-model RAG. A little bit more, I'll take that towards the end. And limitations, for this particular model, the limitation is that it is a basic RAG model. It does not employ um, dynamic grounding or hybrid RAG structure, and RAG often leads to creativity loss, because grounding the response in source documents could lead to an output that doesn't satisfy user needs, and the output is only as good as the source information, right? So yeah, so how does the architecture? I'll take some time for the architecture. So you have to load the document, read the PDF files from specified directory, splitting of text, creating embeddings, storing the embeddings in vector data, setting up RAG chain, that mm, when given a user query, converts the query into an embedding, uses the vector store to find the most similar document chunks, passes the original query and retrieved chunk as context to a large language model, Gemini 1.5 Flash in this case. The LLM generates an answer based on the provided context, um, and the final part of the architecture is provide an interact provide a chat interface that provides an interactive loop to ask questions and display models' responses, and check if the answer is grounded in the documents or not. Here is a representative diagram of the RAG architecture. Um, and let's dive into the code. We 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 downloaded required model packages and libraries, which included Longchain, um, and a database which is a vector database. Um, then for splitting and arranging data, we had LangChain community. Um, we downloaded the Gen AI model, and a little bit of housekeeping action. Now, after importing queues, we had PDF directory loader with which reads the PDF content. Then we had text splitter, which is a lang chain action which basically divides large text into pieces of chunks. Then we have Gen AI, Google's Gen AI embeddings, and Google Generative AI used to create embeddings and Gen AI model. Then we have Chroma, as explained earlier, interface, uh, LangChain interface for the vector database, and then Retrieval QA is a standard chain specifically designed for the question answering over documents, right? Some supporting tools. um, then we made sure that we set up the key. Then we configured the path for input, um, for creating a directory. We used the input command for and then we just tried to see if that's working. And for the 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 database, vector database where the data was stored, made it working, turned it working instead of input, to be able to make sure that it's not read only, to be able to make changes, right, as we stored more documents. So then we had a document processing pipeline, which includes loading and splitting. Then we created functions for embeddings and vector stores. um, then the setting up of the rack chain happened with um, um, uh, which connected the retrieval system with the language model. Then the main execution, which because of some error, we decided to delete the DB, which was there by default, and then build a new load store vector store, um, and then set up. RAG chain um, and created a chat loop. This After the execution, we were able to see the chunking that there were questions that we had. First, we asked a basic questions: what are embeddings? And the answer was a simple answer grounded in the paper. Here are the sources. Um, um, Here are some of the other example prompts that you can use. Depending on the prompt, you will have different responses. Instead of a single question, which is answer is available in a single document. Um, why are embeddings important for RAG, or even more complex, what are the advantages and disadvantages of using JSON, which is sort of spread across multiple documents. You can also ask questions which are implied, which are not directly tackled in the document but are touched on over time. What are the advantages and disadvantages of vector search? You have that information, you get a good answer there. What is the importance of RAG and how can you use vector store to create RAG? Give examples of use cases and code. This is example of asking a detailed question, and you get a fairly long response to this. And then the question of testing if the model is grounded on the documents. So you ask a random question unrelated with when was Jennifer Lopez born. You do the grounding test, and the answer is negative. And then you test the limitation of the model. So you ask it to write a 100-word blog, and while an LLM would do that, this particular RAG model, as I said, lacks creativity. It would not go to that level and give that blog. Of course, you can train that to do so, but these are the example. This is a simpler model to just go through this. So um, there are many potential improvements that can be done, including the one that I just mentioned. Can do with more specific error handling for different stages of the pipeline, and we can implement more advanced track techniques, and including um, uh, we can apply different track techniques, including uh, adding re-ranking steps, use and dynamic source display showing sourcing annotations. You can do we could have added interface, a more um, a better user friendly interface using frameworks like Radio and Streamlit. um, but all in all, the key takeaway from this is that um, with the power of RAG and Gemini, you can unlock valuable insights hidden within your documents, and create powerful knowledge aware applications which have low hallucination tendencies. Thank you.